Your brain can see a face before it fully understands what you are looking at. Two dark spots and a curved line on a toaster, the front of a car, or even a cloud can trigger a surprisingly fast response. Face. Then, only a fraction of a second later, your brain corrects itself. No, that's an object. That tiny mistake reveals something fundamental about how you see the world. Your vision is not a camera waiting patiently for reality. It is an alarm system constantly making predictions about what might matter, and faces sit very close to the top of that priority list. Let's break down why you see faces in things, what happens inside your brain when it occurs, and why these false alarms can tell us so much about human perception. First, the false face. Look around your room, and you can probably manufacture one right now. Two screws above a horizontal slot, two windows over a doorway, a pair of headlights with a grill underneath. Suddenly, there it is, a face. This phenomenon is called face pareidolia, perceiving a face-like pattern in something that is not actually a face. But notice what makes this strange. You usually know the object isn't alive. You don't genuinely believe your electrical outlet is staring at you, yet the face can still feel almost impossible to unsee. Why? Because seeing is not one single event. Think of your visual system like a highly sensitive security alarm. Its first job isn't to write a perfect report describing everything in front of you. Its first job is to flag potentially important patterns quickly. Imagine a security guard watching hundreds of blurry surveillance screens. If the guard waits until every pixel is perfectly understood, something important might already be gone. So the system develops shortcuts. Certain patterns get priority. A face is one of them. That means your visual system can effectively shout, "Possible face," before the rest of the evidence has been fully processed. This is the first important reversal. Pareidolia isn't simply you sitting there and consciously deciding that a cloud looks funny. Experiments suggest that face-like objects can receive priority surprisingly early in visual processing. Researchers have found that people can detect objects containing face-like configurations faster than carefully matched objects without those configurations. Your alarm is sensitive, and sensitivity creates false alarms. Think about an ordinary smoke detector. You could design one that almost never makes a mistake, but if you make it too conservative, it might ignore the beginning of a real fire. Make it highly sensitive, and occasionally your toast sets it off. The alarm isn't useless because it made a mistake. The mistake tells you what it is optimized to notice. And face pareidolia gives us a remarkable window into the same principle inside vision. Second, the fast alarm. To understand why faces receive this treatment, forget the idea that your eyes simply record an image and send a finished photograph into your brain. That's not how perception works. Your eyes receive light. Your nervous system has to extract useful information from it. Edges, contrast, orientation, shapes, objects, and eventually meaning all have to be resolved through interacting stages of processing. And the world doesn't give your brain unlimited time. Someone turns their head toward you, a person appears at the edge of your vision, an expression changes, a pair of eyes shifts direction. Those signals can matter socially, so your visual system is extraordinarily responsive to the structure of faces. Research using brain imaging has shown that illusory faces can recruit face-selective regions of visual cortex. In other words, when you look at an object that happens to resemble a face, parts of the visual system involved in processing actual faces can respond to that resemblance. But be careful with what that means. It does not mean your brain completely believes a toaster is a person. The security alarm analogy matters here. When your smoke detector sounds because of burnt bread, the detector hasn't developed a philosophical belief that your kitchen is burning down. It has detected enough features matching its trigger conditions to activate an early warning. Your visual system can do something similar. A rough configuration appears. Possible face. Check it. That is very different from saying, "This is definitely a human." And researchers can actually watch this distinction emerge over time. Third, the 250 millisecond switch. This may be the most fascinating part of the entire illusion. In a Nature Communications study, researchers examined how the brain represents real faces, objects that produce face pareidolia, and ordinary objects. Early in processing, the neural representation of an illusory face becomes more face-like. The alarm fires, but that state doesn't last. Within roughly 250 milliseconds, the representation shifts. The same stimulus begins to look more like what it really is, an ordinary object. Think about how fast that is. You look at the front of a car. The arrangement of headlights and grille provides enough structure for the alarm system to flag a face. Then additional information arrives. Metal body, windshield, wheels, road context, car. The first interpretation isn't simply erased. Instead, your perception resolves the competition. This is why pareidolia can produce such a strange subjective experience. You can see the object and the face at essentially the same time. You know it is a coffee machine, but it looks annoyed. You know those are two bolts and a curved seam, but somehow it looks happy. The illusion survives even after the object's identity becomes obvious because different levels of visual processing are extracting different kinds of information from the same image. One system is asking, what object is this? Another is sensitive to, does this arrangement contain something face-like? Both can produce useful information. So your experience becomes layered. Coffee machine and face. The security guard has checked the alarm and discovered there is no intruder, but the pattern that triggered the alarm hasn't disappeared. You can still see exactly why it went off. Fourth, why the eyes matter. Not every random collection of shapes becomes a convincing face. Configuration matters. Two eye-like features with something beneath them can be enough to produce a powerful impression. Move those pieces into the wrong arrangement, and the effect can weaken dramatically. That tells us something important. Your brain is not merely searching the environment for individual circles and lines. It is sensitive to how features relate to one another. But recent research also adds an important complication. It would be tempting to tell a simple story. There are face neurons, random objects fool those neurons, and that's the entire explanation. Biology is rarely that tidy. Work examining face-responsive cells in macaques found that responses to pareidolia images could be strongly influenced by local object parts resembling facial features. Human judgments of how face-like an image appeared, however, depended more strongly on the overall configuration. So the illusion appears to emerge from interacting levels of visual analysis rather than one magical face switch. Think again about the alarm. A sophisticated security system doesn't rely on one sensor. A door sensor contributes one signal. A motion detector contributes another. A camera contributes another. The final interpretation depends on how those signals combine. Visual perception works through interacting representations too. Individual features matter. Their arrangement matters. The object surrounding them matters. Timing matters. And together, those layers can create the unmistakable experience of being stared at by a backpack. But your brain doesn't stop at merely detecting the geometry of a face. It can begin reading the illusion socially. Fifth, the expression illusion. This is where pareidolia becomes genuinely strange. When you see a face in an object, it often doesn't look emotionally neutral. A house can look surprised. A car can look aggressive. A piece of fruit can look miserable. A power outlet can appear shocked. Nothing inside those objects is feeling anything. There is no nervous system behind the expression, yet people can reliably perceive emotional qualities in these accidental faces. Researchers have found evidence that mechanisms involved in processing expression in real human faces also contribute to how we interpret face pareidolia. So once the alarm identifies enough face-like structure, additional systems can begin asking questions normally reserved for actual faces. What expression does it have? Where does it seem to be looking? Is it happy? Angry? Surprised? This is important because faces are not merely visual objects to humans. They are social information. A face can tell you where someone is directing attention. Facial structure and movement can provide clues about emotion and intention, so detecting the presence of a face is only the beginning of the job. Your brain also has systems for extracting information from that face, and some of those processes can spill over onto objects. One study found that the apparent gaze direction of illusory faces could influence subsequent perception of gaze in real human faces. Think about what that means. The false alarm can enter the same processing stream deeply enough to influence what comes next. The object doesn't merely resemble a face in the abstract. Your brain can begin treating its apparent eyes as socially relevant information. Again, this does not mean you consciously believe the object is alive. Your higher-level interpretation knows better. But early and intermediate perceptual machinery can still operate on the face-like pattern. The alarm has triggered downstream systems. That's why some pareidolia faces feel almost alive even while you know perfectly well that they aren't. Sixth, why false alarms happen. Here we need to separate what experiments demonstrate from a very tempting evolutionary story. It is easy to say, humans evolved face pareidolia because seeing a face quickly helped our ancestors survive. That sounds plausible, but plausibility isn't proof. What the evidence supports more directly is that human vision contains highly responsive mechanisms for detecting and processing faces, and those mechanisms are broad enough to respond to some non-face objects. The false alarm may therefore be a consequence of sensitivity. Imagine adjusting the sensitivity dial on our security system. Turn it far down, and almost nothing triggers it. False alarms disappear. Sounds perfect. But now weak signals can slip through. Turn sensitivity up, and ambiguous patterns get checked more often. You catch more potential targets, but you also increase false positives. Perceptual systems constantly operate under uncertainty. Light changes. Objects are partly hidden. Faces appear at different angles, distances, and sizes. You cannot demand one perfect portrait before recognizing someone. The system needs flexibility, and flexible pattern detection comes with a price. Sometimes a sink looks horrified. This gives us a much better way to understand pareidolia. Your brain isn't necessarily failing when it detects the face. It is revealing the threshold at which face-like information becomes important enough to inspect. A false alarm exposes the architecture of the alarm, and this principle extends beyond faces. Perception is full of inference. Your brain receives incomplete sensory evidence and has to construct the most useful interpretation it can from that evidence. Usually, this works so smoothly that you never notice the construction happening. Pareidolia catches the system in the act. For a fraction of a second, you can almost watch perception negotiate with itself. Face, object, face-like object, resolved. And modern computational research makes this question even more interesting. Work using deep neural networks optimized for face and object recognition has found that human-like face pareidolia can emerge from interactions between systems dealing with faces and broader object recognition. That doesn't mean an artificial neural network is a human brain, but it gives researchers another way to test which kinds of visual computations can generate face-like false positives. The emerging picture is more interesting than the simple idea that one face detector gets fooled. Your perception is dynamic. Different representations dominate at different moments. The alarm can activate early. Object recognition catches up, and your final conscious experience contains traces of both. Seventh, what pareidolia actually means. This is where internet explanations often run far beyond the evidence. If you see faces everywhere, does that mean you're unusually creative? Not established from the evidence we're using here. Does it mean you're more intelligent? No conclusion like that follows from these studies. Does a face in your curtain reveal a hidden personality trait? Number. An ordinary face pareidolia by itself should not be treated as a diagnosis. The scientifically interesting part isn't a secret message hidden inside the object. It's what the illusion reveals about perception. You are not passively receiving reality. Your brain is continuously organizing sensory information into meaningful possibilities. And some possibilities receive priority. Faces are special because your visual system has extensive machinery dedicated to processing them. Give that machinery an ambiguous object with the right ingredients, and the system can briefly apply a face-like interpretation. Then other processing catches up. This is why the illusion can be both obvious and ridiculous at once. You see the face. You know there is no face. Neither experience has to cancel the other. And once you understand the mechanism, ordinary objects become little demonstrations of neuroscience hiding in plain sight. The next time you see a face in a car, don't just look at the eyes. Notice the entire process. There is the instant recognition, face, then the correction, car, then the strange coexistence, a car that still somehow looks like it has an attitude. That sequence is your visual system revealing its priorities. The security alarm fired because the pattern crossed its threshold. Then the rest of the system inspected the evidence and resolved the object. Fast detection first, detailed interpretation second. And that distinction matters because we often imagine perception working in the opposite direction. We assume the brain carefully analyzes everything and only then decides what it sees. Pareidolia shows why that model is too simple. The world arrives too quickly and too ambiguously for vision to operate like a slow laboratory technician. Your brain has to make rapid bets. Most of those bets are so accurate you never realize they happened. A face in a toaster is different. It lets you catch the prediction before it disappears. That may be the real reason these illusions are so compelling. They expose a hidden stage of seeing that normally remains invisible. You are looking at an object, but for an instant, your brain has already asked a much more important question. Could that be a face? The answer arrives almost immediately. No, just a toaster. But the alarm already rang, and once you hear it, the face can become almost impossible to unsee. So the next time a house looks surprised, a cloud seems to smile, or the front of a car appears angry, remember what you're actually witnessing. There is no person trapped inside the pattern. There is no secret message in the object. You're seeing the machinery of perception expose itself. A visual system tuned to notice faces can sometimes notice them where none exist. That's the trade-off of a sensitive alarm. And every accidental face gives you a tiny glimpse into how quickly your brain turns raw visual information into a meaningful world.